In this video, I'll go through a quick example how to use superposition, which is an important concept when analyzing circuits. So in this example, I have this circuit that I'm showing here. So 9-volt DC source, and you have these resistances, and also there's another 6 amp source, then 15-volt DC source. So, and I'm asked to calculate this voltage across 6 ohm resistor, which I called Vx. So we're going to solve this problem using superposition. Basically, we are going to turn off all independent sources. If we have dependent sources, we have to leave them in the circuit as we go through this exercise. But in this example, to keep the matter simple, kind of show how to use superposition, I'm only using independent sources, except one source. Basically, you turn off all the sources, you leave one source at a time. So you leave one source, independent source, and you go through, you calculate that voltage. And you do that for all the independent sources. And I'll go through this example. For current sources, basically you open them, and for voltage sources, you short them. So I'll show how to do that. So now, let me just get a different color here. So now, let me start from the original circuit. So what I'm going to do, I'm only going to leave this independent source, the 9-volt DC source, on. So you see here it is on, and you see the 6 amp here, the 6 amp source is basically open, and I shorted the 15 volt DC source. So that's the circuit I will get by leaving only the 9-volt DC source. So then I can further simplify the circuit. Notice since this is open, basically this does not exist, so I can just remove it. So I only have the 3 ohm resistor in parallel with the 6 ohm with the voltage, I called it Vx prime, is dropping across the two resistances in parallel. So basically I found the 6 ohm in parallel with 3 ohm is just 2 ohms. So I redrew the circuit, just kind of look more pleasant and more easy or easier to analyze. So the 3 ohm basically I just put in parallel with the 6 ohm, and you have the V prime X. I called it V prime X voltage for this particular case, which is basically is dropping across the 6 ohm in parallel with the 3 ohm. So then I can just, to find V prime, Vx prime, I can just use voltage divider. So it's 9 volts times 2. And I got 2 from, which is the equivalent resistance of 6 ohm in parallel with 3 ohm that I show here. Because basically, to simplify the circuit, you have the 9 volt and you have the 2 ohm resistor, and you have the 2 ohm resistor found from 6 ohm in parallel with 3 ohm. And obviously this voltage here is V prime X. That's what I'm doing. So V prime X, it turns out to be 4.5 volts. So now I only want to leave the 6 amp source on. So that's what I'm showing here. That means I'm going to short this voltage source and short the other voltage source. So notice after doing this, the 2 ohm resistor is in parallel with the 6 ohm. So if I calculate their equivalent, it's 1.5 ohm. So I can redraw this circuit here into this circuit. So I have Vx second, so I called it Vx second, and I have the equivalent resistance, which is 1.5 ohm, and I have the 6 amp source, and I have the 3 ohm resistor. So I can use current division. Basically, this circuit here, you can think of it like this: 6 amp, and you have the 1.5 ohm, and then you have the 3 ohm. If you want to rearrange it, so I can do current division to calculate the current that flows through the 1.5 ohm resistor. So it's 6 amps times 1 divided by 1.5, the entire thing divided by 1 over 1.5 plus 1 over 3. So I get 4 ohms. 4 amps. Then I can do Ohm's law across the 1.5 ohm resistor. So Vx second is equal to I times R. So it's 4 times 1.5, which is 6 volts. So I found Vx prime to be 4.5 volts for when I left 9 volt on and the other sources off. Now I found Vx second to be 6 volts when I left the 6 amp source on. So now I'm going to do the same thing for the last source, which is the 15 volt. So basically I just want to leave this source here on. Since 6 amp is a current source, so basically it's just open, and the 9 volt is a voltage source. I'm going to short it, basically. That's what I'm doing here. So again, notice 2 ohm is in parallel with 6 ohm, so their equivalent is 1.5 ohm. And I can rearrange basically 15 volt is in series with 3 ohm, in series with the 1.5 ohm resistor. So I already calculated these two. Now I can use voltage division basically. So Vx third is equal to 15 volts times 1.5 ohms divided by 1.5 plus 3 ohms. So it's 5 volts. So V prime, V second, V third of X voltage those are the corresponding voltages when I apply superposition by only leaving one independent source on, at a time. So to calculate the voltage, Vx is the sum of all the voltages that I calculated. In my case, I have 3. So basically, I just sum them. And that is, sorry. So that is Vx is 15.5 volts. Obviously, you can calculate this directly, but it can be tedious and time consuming. So superposition comes in handy, especially when you have a complicated circuit. Thank you and have a great day.